Hey everyone, my name is Nick Disalvo and I'm an undergraduate student at the Stevens Institute of Technology.
And my name is Michael Cerreto, and I am also an undergraduate student at Rutgers University. For our project, both me and Nick created an end-to-end pipeline that allows users to generate their own custom state-of-the-art 3D meshes that can be generated and integrated into Speckle with just a few clicks of a button through our state-of-the-art, user-friendly web application.
Our inspiration for this idea stemmed from observing one of Speckle's primary goals, which is facilitating the seamless exchange of intricate geometric and attribute data among diverse software platforms like Revit, AutoCAD, Blender, and many more. The mission aims to simplify data creation and management within the AEC industry by allowing users to effectively use all of the tools at their disposal without having to deal with the overhead of transferring progress and data throughout a plethora of different individual applications.
We thought that a way to contribute towards this goal is by allowing the users to create intricate 3D meshes from scratch in seconds with instant speckle integration. This is as opposed to spending significant time and effort on manual mesh creation processes. So, without further ado, let's jump right into our project. Starting with our website, which was built using Next.js and a Flask backend, users can elect to hit the Create button. This redirects them to the 3D mesh generation page, and from here users can either input a 2D image or use their camera to take a real-time live photo to generate a state-of-the-art geometric figure. The 2D image is then processed through a pre-trained conditional stable diffusion model through the Gradio API, and here's an example of me inserting a 2D image from my computer. The total process takes about 30 seconds, and after the user's mesh is generated, they can either convert another image by hitting the Convert Next button, download the mesh by hitting the Download button, or add it into Speckle's client with the use of Speckle's Python SDK instantly by hitting the Add to Speckle button. Now here's an example of me using my camera.
Let's now take a closer look at how users can add their 3D mesh into Speckle's client. First, they must redirect onto the Speckle page, and from here they will be required to input their Speckle authentication token, the name they want to call their newly created data stream, and the 3D mesh they want to upload into Speckle's client. Users can also receive data from their data streams by inputting a stream ID of a previously created stream.
Something that we also included in our project is a feature that allows users to view and download 3D mesh creations made by others. To enable this, we utilized a MongoDB database to track image URLs and user sign-ins through NextAuth. As you can see, we save all the URLs here and all the user info here. So, to begin the process of saving your meshes, users can sign in by clicking the top right sign in button and follow the steps to log in with their Google accounts. From here, they can click on the Collection tab on the nav bar, where they are directed to the gallery of all 3D meshes generated. As you can see, we have generated about 10 meshes so far. Additionally, they can also hover over each mesh and either download them or click on the View button, which takes them to a page where they get to see an expanded version of the mesh. Lastly, if users type a username in the URL, they can see all of the 3D meshes that the person has generated.
At this point, you have now all seen the functionalities and technologies of our web application. If you want to see the code that makes all this possible, it is all included in our GitHub repository, as well as an extended video that goes into our technical implementation details on the project. This includes us going into detail on what libraries and languages we used, as well as what it took to complete the code, such as our design process and the struggles we went through along the way. There are still many features and improvements that we're excited to implement in the future, and I hope you enjoyed seeing our web application in action. And I hope by our project and the recent progress in AI, especially stable diffusion models, we are taking a step further in advancing the efficiency of the workflow in the AEC industry. Thank you guys.